So let's go ahead and talk about what your exercise in class today is. I'm going to put it up on the board, and then I want you to separate in pairs to do this. Okay. So our permutation is basically, just an ordering of something. So let's look at the word and. Oops, sorry, wrong one. So and. So let's go ahead and look at, so and is a permutation of and. Let's look at some other permutations of and. A, D, N, addin, or something like that. D, A, N, D, N, A, and then N, D, A, non-disclosure agreement. Let's see, NAD. Right, so we've got a couple different combinations that we can go, and these are all permutations of and. Are these all the permutations of and?
Yes.
Yes? Okay. How many permutations are there? Oh, there were 3 factorial. Right? Why was that? Because I can choose, because say I've got something that's like 5 letters long, like hello. I can choose one letter. I can choose one of 5 letters to go into the first position. Then 4 letters, since I've chosen one, there's only 4 letters left that can go into the second. Then there will be 3 that can go into the third, then 2, and then there's only 1 letter remaining. So you have 5 choices times 4 times 3 times 2 times 1. So that's how many choices you have to make. So there's 5 factorial permutations of this. So the question of the day is, can we write a function that, given a string, produces all permutations of that string? This is actually a surprisingly hard problem, even though the amount of code that it requires is maybe 4 lines, 5 lines. Somewhere it's less than 10. It requires less than 10 lines of code to do this. But it's actually a surprisingly difficult problem, with a lot of, and especially because the way we want to try to solve this is recursion. Also, it takes a long time to do because there's n factorial combinations you want to come up with. Like, yes? Right. If there's multiples of the same letter, but we're going to make our program pretty dumb. So it's not, so as far as it's concerned, L1 and L2 are completely different. Right? Don't want to add any difficulty to this right now. Later, maybe in a future homework assignment, we'll take what we do here today and move it over. And I don't even know if we'll be able to finish this in class today. Who knows? That's what's the fun about this. But rather than trying to get in deep into a new topic right before spring break, when you're likely to forget about it, I figure it's best to try working on something like this, and then do maybe a bit of vocabulary on trees on Wednesday. But I feel like your time would be better spent here. So what I'm going to do over here is that I'm going to create basically a new assignment under the quizzes. When you're done, you're going to upload or whenever class is done, you're going to upload the work you have. You will automatically get full credit for it. So no pressure to complete it in the allotted time. Got it? So it doesn't matter if you solve it, you don't solve it, you'll get credit for it. That being said, it's a useful exercise. This is actually an interview problem. So it's kind of a really good thing to do. So now to make this more interesting, though, I don't want you to go alone, because this kind of thing is kind of terrible if you try to work on it by yourself, and you're likely to bang your head against the wall. Instead, what I want you to do is try pair programming. How many of you have tried pair programming before? How many of you even know what pair programming is? No? Okay. So that means that only actually half of you are going to be working today, or at least have hands on the keyboard. The other half of you are going to be looking up over the shoulder of somebody else and basically asking them questions, pointing out mistakes, discussing the problem with them. Okay, one is basically driving, and the other person is navigating. Is essentially the way it's going to work. So what I want you to do is to start is pair up. Just find somebody by you, find somebody who's not by you, pair up, and get together with somebody. And basically, if you're not the person working, put away your laptop. You're going to be sharing one laptop. You might be passing it back and forth. Okay? And I will basically suggest that people swap every so often, so that basically that you get a change of perspective. All right. All right. So now to make sure that the other thing I want to mention is that to make sure you both get credit for it, make sure you both upload a copy. Okay. So you'll want to email it to the other person and just so they can both put both your names on it. You know. So there we go. So again, the problem is basically given a string recursively. Give me all these things back. Now let me specify this a bit further. I don't need you to like return an array or a list of all the permutations. You can do that if you want to, but you can also just print out all the permutations. You can just print out all the permutations. Also, let's think about if we're going to solve this recursively, let's think through the base cases. What is the base case? So right now, go ahead and discuss basically what the base case for a permutation is with your partner. Right, the base case is going to depend on your input. So what are possible input? What input basically would you like to see be the base case?
I think it's going to be, like you said, your 5 letter. So you pick that letter, then you have that letter first.
All right, at this point, I'm going to go around and discuss it. Let's go ahead and
That's kind of, I don't know if that's
I'm still trying to word is empty. So what do we need to list for? I was just going to use it to build a list of all the I don't think we need that as like a function argument because the list will just be like the size of the list will just be like the factorial start. But how do we access just be like just be an empty list. I mean, I was just gonna do an array to find how cool like it might be better as an array. I think an array would be
Just seeing where you have so I don't know if I gave you all correct.
Alright, the function itself is going to return like a possible permutation of the word.
It will print out. So it's easy if you print out all possible. The question is, where do you know? How do you know to stop? You got all the possibilities. Might be easier if I give you guys a bit of a header on this one. So let's go ahead and give you a bit of I'll throw you guys a bit of a bone here. They set up the function. Okay, so Notepad. Permutation, string, word. String. All right. So here's my hint, which may be too much of a hint, but we'll see. That is my hint to you guys for the best way to set this up and to keep track of stuff. So basically, first off, the top function, your permutation function, should call a recursive function, right, to solve this. The second thing is then figuring out the recursion and what do you need to solve your recursion. I should have also helped if I could spell. So we don't really need to return anything in this case. So in this case, when I asked what the base case is, when I asked that, I was asking so what word would be really easy to figure out a permutation for? Anyone?
One letter.
One letter. One letter is a pretty easy to figure out what the permutation is for. There's another answer, even easier, but that one's a good one. That's a perfectly balanced stopping point. No letters. Empty string. Empty string is a perfectly balanced stopping point. So if basically if you have no letters left, in other words, let's go ahead and take a look at that function I wrote there. Current. That's what the permutation we're currently working on. Okay. The rest, and then the second one is the rest of the word, which is basically the rest of the word that we have to figure out the permutation for, right? The rest of the letters that we can select from. If that's empty, then we should just print out what we have.
So the rest of the word is the remaining letters.
So I'll walk around and basically answer your questions as I see you guys get set up.
Whatever string of letters is currently in the permutation.
Yeah. I mean, the easiest way to check this is to basically check if the word right? And then that would be
So I guess this is where.
recursive case is what's actually on. Yeah. So
So you want to check if the rest is
let's
empty.
think about it.
Yeah, that'd be nice.
Yeah.
Yeah, so we have to.
Okay, so how would I go about getting all the
Yeah, that's it.
Yeah, that's weird. They're both void. Which one is I guess the first one.
We have to choose a random letter from the rest and add it to current. And we have to check if that letter we added is a permutation we already did. Can we call multiple permutations from this permutation? Yeah, we should be able to call multiples these from here. My understanding of it is it goes something like we do it for our word, and then we call the same function again, and if it's
so then we can send the rest of the word. Yeah, well then what if you give rest of word is take one letter. So if I guess there's a word below.
I would do
It's what I've been thinking is like, if our string is hello, like current is HE, and we have those, we can start by like adding L to HE, and so like that'd be like we'd add that to like all the permutations, like at least be part of that permutation. And then like if we did this already, for the next time we call the function, we could go through the other so we have
Yeah, it's just like
hello rather than us, we can go to the same thing. So we're back
so now.
so like yeah. Recursive background.
Then I go back and say, okay, so I guess
The return type should be very important. So if we were turning a string with everything, we just need to how are we going to keep track of like every recursion? Should we just have oh wait, I think okay. Times for each character. You know, I think you're right. Actually, each you get. Okay, I like that. Because then we know that's a like comparative. The listing would probably work if we were doing like the where it's like we don't count words that are the same.
You can return what you want. You don't have to. This is the general idea over there where basically you switch one in place and then you call permutation on so you fix one in place and then call so the other way. So string current is all the stuff you fixed in place. Rest of the word is the stuff you have.
So I think maybe not.
Well, you want to go through all the characters that are in the rest of the that is the correct structure.
A number of letters and then send the rest to make permutations. Fix them out and so I guess that sounds like
So in the first one, it would call this function with like the empty string being current. That it would like I guess the idea would be like kind of for like each character in the rest. For each character in rest, print like all the permutations of the current with that letter added on. So if we have the empty string given, maybe like Yeah, I have that. The hard part is getting rest. How do you put the character index in order? I just put it right in that what it's doing. So push it again. The character index I from rest. That makes sense. So do we not know the I don't know. I'm just gonna write one. I feel like it's too basic of an operation to not be included.
So then I get to just say I to for I plus one.
Then it would send ELO and say, okay.
So string builder has a method. So you just call the string builder for activating string builder. Yeah.
I feel like we're not really making a permutation.
Okay, now we need to create and you just call it
Very flat.
which will be
Well, do you think we should turn the word on?
yeah.
There's no more work.
I don't think so.
So now we have a character.
Currently,
Yeah,
I think we don't want. So the first thing to do is
So we need to
the first thing to do is throw it. And then then throw
All right. So one of your classmates had found a diagram that I found that I thought was rather useful, and I'd forgotten about it. But permutation of all permutations of a string. As you can see, it's a common problem. Let's see. So here is something that somebody found on class, and I thought was particularly a good one. Let's see. All permutations of string. Now I just want to open the image. So the idea here for this problem is that we lock each of you look at it, if you've got 3 letters, you want to lock the first letter into place and then figure out what the permutation is of the rest of the letters. Then you lock the second letter into place as the first character and figure out what all the permutations of the second one is. And each of those calls is recursive. So basically, so here we lock this into place and figure out all the rest of the permutations. So the idea here being is that as I was going through and explaining to a lot of other class members was, let's go ahead and look at the string help that I was doing, H-E-L-P. The idea here is that I'm going to lock H into place, right? And then what I'm going to do is I'm going to figure out all the permutations of E-L-P, which is well, to figure that out, I need to figure out all the permutations that start with E, or start with H-E, and then end with L and P. So that would be L and P and P and L. Then I lock P into place, and let's see, that would be the rest of the remaining letters are E and P. So I figure out, so I choose one of those, lock into place, and then lock this into place. And I back up to here, and then finally I do H, L, E, and P, and H, L, P, or EP, and then P and E, right? So that was, so I figured out all the ones that start with H, and I'm like, okay, to figure out all the ones that start with H, I need to figure out all the ones that start with H and E. To figure out all the ones that start with H and E, I want all the permutations that start with H, E, L, and then all the permutations that start H, E, P. And okay, and then once I figured out all the ones that start with H and E, I went on to HP, then to HL. And now that I figured out all the ones with H, I can do H, and the remaining, start with E, and the remaining letters are E, L, P. So H, E, L, P, E, H, P, L, E, L, P, H, E, L, H, P, and then E, P, L, H, E, P, H, L. Right, and then I'd move on to all the letters that start with L and figure out, basically the recursive call is, so here, right, with the code that I have up, or the headers that I have up for you guys, the idea here is we want, current is all the stuff that you've currently said, this is the current permutation I'm working on. Current is current permutation. And rest of the word is all the rest of the characters that I have to figure out whether I'm going to throw them on. And so we said for our base case, if rest of word is equal to, if that is, well, let's say dot equals the empty string, right? If that equals the empty string, we're just going to, we're done. So if you're saving stuff, you can return it. Otherwise, you can and add it to the list. Otherwise, you can, S out your current, right? And the question is, so that's your base case. Now the question is figuring out your recursive case, right? And to figure out your recursive case, well, we need to choose one of the characters to lock into place. And then we figure out the permutation of the rest of them, which means we need to go and iterate through every single character and look as though each one of those is locked into place. So basically, for int I is equal to 0, I is less than rest of word dot length, I plus plus. And now, then you figure out your recursive function, figure out your recursive calls in here. So that's where we want to go with this. If you're getting a Stack Overflow error, then that means you're kind of got into an infinite loop. It's not ending. Yes.
We have a solution, but I don't think we're backtracking.
Oh, you're backtracking if you got a solution. This one isn't backtracking.
Yeah.
Right. With the recursion, you backtrack automatically. Here, you point at the list that we are. So you got your string go to left. So lead character at I. Right. And the way we do string, by the way, is to do it with character reference. Is to use character reference substrings.
I was gonna write a method to do it, but
All right.
suggested string delta would be
So yep, singular is good. So if you want another one to work on, that's easier to know that you know. Let's look at the second problem.
So that was
No, that was exhaustive. But I mean, kind of use backtracking. All subsets of a set. Let's go with the power set. Let's go with a string. All subsets of a string. Finding all sets. So basically, print out all substrings of the string. There we go. Basically, in an ABCD, print out B, A, C, D, ABC.
So for this,
Basically, the idea is that we don't care. These are we consider these to be sets. We don't care about the order. Basically, print out all possible. So we're not caring about all possible permutations. Here we're caring about all possible combinations. Right? So combinations are permutations. Yeah. All possible combinations. All combinations aside from our own, because all sets they'll have the answer down there, but so it's not it's a different call. But the call you make is whether or not to include something. It's going to be 2 to the n. I think it's 2 to the n.
Yeah, it's 2 to the n times the number of characters.
Yes.
Yeah, 2 to the n.
So if you are working on this and you've been working on it for a while, I would suggest maybe swapping roles. The person who's been typing maybe should take over, and the person who's been guiding should now.
So the question is how do we get not just wait a second. Right, you mentioned there's a between so we don't really have a use for like all of these different permutations. What I'm saying is
you don't work on this first.
The reason is because right? So you're adding
I mean, that was just my initial thought. I don't know a better way to do it. You can delete all of those.
So, oh, So you don't want to, the same problem you are adding to, you're adding text.
Then you go back to this, then you go back to this.
Right.
Yeah.
You just add that straight in. You want to iterate.
We're still left with a combination problem, because if we do H and then all the combinations to be LP, we need all the combinations.
No. Base case is like rest.
Then you have parity.
There's a lot of errors. The logical sound. The logical sound is that. Good job.
I feel like we need to rethink what we call it.
So now, if you want to keep working, here's the second problem.
So let's take a word and like list all the combinations.
Here's the second one. Okay, rather than printing out all permutations, I want them all common. So I would need for A, B, C, D, A, B, C, D, I want A, B, C, D, A, B, A, C, A, B, BC, okay, BD, and then CD, ABC, basically there should be either, if you have 10 characters, you have 2 because words. So this also called the all subsets of set. Basically here, what does it matter?
Well, Send a short rest of word.
That was the trick. Very simple.
And this is the one that should
It's just something else to work on so that you're not wasting your time.
So current is everything.
You got something? Take a look.
Current fixed everything. If not current, at some point, it said current is A, B.
Okay. Over here, you're not really doing this much.
I want to set,
And
I want to iterate over the rest of the words out blank.
yeah, right now, okay, yeah. Now all you want to
So
do
what we
right
just
away
did was A, B,
is to do a single call.
C, D.
Okay. All you want over here is to do
And we're iterating over the rest of the words out blank.
So hear me out. So you have 4 letters, which you can map to 4 bytes, and then we just need to find
basically starting with all the
all
stuff that we want to do so far,
different values of those bytes,
and we still have all the rest of the characters to do.
just map it back to the
Right?
Okay.
Okay. So that's fine.
So each would be 1, 0, 0, 0.
Okay. So now it's again even more.
Okay. And each should be this way. It's gonna be
Okay. So basically those are each character like
I think I see it.
H's.
So yeah.
Adding that to the code.
Whether or not each
And the
thing
way you remove the easiest way
Right.
to remove stuff without
Yeah, I get why the bits were big. We need to starter map.
is you can go up to the character you're wanting.
And then we need that.
Skip over it and stuff.
And we need that to create the manager array.
See you
Oh,
guys.
yeah.
Past that. Yeah, so what I pass an array, like, I'll just do it in the notes for now. You can, like, copy paste it.
So you need a combination of the first one.
Alright, so what's the
I mean, it could be a Boolean array too, I guess.
Or Boolean, it really doesn't matter.
Yeah, all you have to do is make the array as part of the code, and then so that way when you get tested, maybe that was saying iterate over C. It should be so like
So if the first HTML statement you need to create a character array or an integer array or Boolean array for that.
Yeah.
the array list will have to be what we want to do is fix
So the more complicated array calls the word we're using and then the array. Or
Yeah. The word and then the array.
All right, so I'm going to go ahead and put the answer on the board for you guys to take a look at. Then I have to open up a place for you to submit it, so that's why I'm going to do it now. So it's actually surprisingly short, the amount of work you have to do here. So the first thing is basically we want to let's see. So here's our initial function, permutation, and we just call because when we start with a permutation, we basically have nothing to work with, right? We start out with nothing's created for our permutation yet, and then we go and we pass in the word as the rest of the words because we still have to solve the rest of those. Now over here, permutation, and then let's see, current plus rest of word dot car at I. Okay, so basically that's where we basically so here if we pass in word first and we got this empty string over here and we've got help, it will be this will start as H, then it will be E, then it will be L, then it will be P, but we've got to remove that character from the rest of the words. Okay, so how do we do that? Well, some people use string builder. I'll use substring for this. So rest of word from 0 to I plus rest of word I plus 1. And sorry, those are substring operations. Substring. And I'm not typing this into a compiler, so I hope to God this works. But I think this should work. So somebody try that out and see what mistake I made. What, doesn't work? Okay, what does it do? Null pointer exception? Or what? Stack Overflow? What? Can't refer what? Stack contents. Let's see. Let me see what you have. Let me see what you have.
Just like different.
Oh, okay. Yeah. Sorry. You said static. Static. My bad. There. Static. Now it's the static method. So does it work? Let's go ahead and find out, shall we? Mm-hmm. Okay. Here we go.
The number of characters in the word, like it's 3 to the power of the number of characters in the word.
Permutation. Hello. Editor does not contain a may type. Why doesn't? Oh, right. That's silly. So I got him cut. So hold on a second. Cut. Really? What the heck just happened there? Oh boy. No, my IDE decided to be silly. Yeah, I need to do system.print line over here.
Oh, I know the missing combination.
I was just doing it as shorthand for you guys on the because it was originally just on the board. String, args. Okay. Okay. Permutation. Hello. Run. So yeah, looks to work just fine. Okay, so that's your solution for this one. So here's what I'm going to do. I'm going to create a space on canvas for you guys. Okay. Let's go over to data structures. Assignments. So over here, what I'm going to do is I'm going to create a new assignment, but instead of going under assignments, it's going to go under quizzes. So it's going to go under quizzes. So it's going to count as one of your quiz grades. Should be 10. 10. Allow self sign up. 2/26. I don't know how this works, so let's go and see if anybody wants to test this out. You're more than welcome to. Online, but basically, if you submit a copy, we'll go through and give you credit for it. We aren't really going to take a look, so just upload what you have just to make sure that you were here today, essentially. And now if we go to assignments, you'll see underneath the quizzes there will be something to upload there to your quiz grade. So that will work as your participation grade for the day. All right. So what did people think about this general thing, though, this working in class on a problem? You thought it was good? Yeah. Okay. So my hope is that after spring break, I might do a couple more flipped lectures. There will at least be 1 week which is entirely flipped because I'll be out for that week, and that will be like end of March, early April, where basically you'll come in and the TAs will be here, or your TA will be here and they'll be supervising essentially this, and it will be essentially extended lab sections for you guys. So this is the first time I've had you guys not clamoring for the door when the lecture's over, so I guess that's a plus. So, okay.